Hello, my programming engineers. I hope everyone is great. Welcome to this PLC Animator course, specifically directed to the PLC Animator app and PLC Academy members. Now, for this quick course, the introduction for automatic industrialization, I don't want to waste any more time, so we're going to start with our topic that we're going to start looking into this presentation. Now, why don't I want to get so deep into this? Because we have a lot of course ahead of us. And I want all our topics and courses to be very clear, especially the most basic of these terms. What is industrial automation? Why is it so important? Manual processes versus automatic processes. Now, for example, we have example number one, example two, uh, process controls, specialty studies, and without further ado, let's move on. First, what is industrial automation? There are many concepts, but I'd like us that you really be honest with yourselves. Okay? So we're going to go back a little bit. After I showed you this slide, this is the quickest concept for which we were defining, along with experience, and a concept for which I wouldn't want you guys to forget this, which is what is industrial automation? So pause this video and really answer this. Not just because you saw the concept or whatever, but I'd really like you guys to explain what is automation. Now, I'm going to explain this to you. These are the activities or the compound processes which convert prime material, and that's where we should focus on these three words. Convert prime or raw material. And then after this, they turn into final or end products by using machinery and technology, looking for efficiency and quality. It says here, technology based on informatics, electronics, mechanics, etc. So since you're looking at this from the industrial automation concept, same as with our textbooks in grade school, which told us, or in during our college studies, what is the process in which we turn raw material right from where we get wood, and then the process for laminating and etc. for temperatures, etc., etc. So we need to add pressure. And then what do we need to do? Well, if we need to cut this, all of this process, all of this procedure in reality, it is all either manual or it's automated. If it is automated, then what we're looking for is a better improvement and quality. Now, why is industrial automation important? Many people say, well, this is the future of, the future of college courses and college degrees is odontologists or doctors or in the software development. Everyone, the current generations, they all think, and to some extent, they are correct, that it's software technology, which they may be true. Mobile app programmers or video game developers or web designers, there's a ton of things and studies that new generations are focused on software development. But no one is paying attention to industrial automation. Whenever we go to a party or whenever we're with family members and they ask us, So what did you study? Oh, I studied mechanics engineering or industrial automation, or I'm a technician in the electromechanics or electrician. But the main focus is I'm a PLC programmer. And what do people say? Oh, that sounds so interesting. But you have no idea the importance of that career. But I'll tell you something. Everything that we see all around us are products. Cell phone, for example. Where are you looking at me from? Cell phone or a mobile phone? I have a lamp that's providing me my lighting. That's a product. My clothes that I'm wearing, that's a product. My chair behind me, that's a product. The microphone that I have, that I'm wearing, that's a product. Everything that we have physically for which we exchange an economic value for that product, then that means that we are all interested in acquiring something, a car, a house, which in the end, they are products. Now, how are houses made? Concrete, bricks, wood. Every piece of product that is inside of our house had to undergo some sort of a process. Now, you may say, well, you can also do manual products. Okay, that's true. But this point is very important because even though this is an industrial automation course, and if we go to a community where they do woven products like t-shirts, sweaters, sweatshirts, or if they're selling uh, manual artisan spoons, everyone has their own process. Now, currently, if we listen to the news and if we analyze our data, this is why the growth is important. That's why this is a career that is not slowing down. It's not the same thing that I have someone doing some artisan work by running spoons than if they work on machines. Machines, they can produce up to 5,000 spoons an hour. And how long does it take a person to run this process? So it's these type of analysis that we're going to start running for this presentation. Okay. So we're saying raw material is transformed into a product. Now, let's focus on industrial automation. That is our job. Optimizing our processes from beginning to end, start to finish. Because when we do a product or when we make a product, we use many processes. Think about this. Even from milk from a cow, where does it start? And all the procedure where we have to burn the bacteria, we need to pasteurize, mix. There's a ton of processes so that in the end, we get the milk cartons in our stores or shopping malls or wherever. Now, we are going to run the efficiency or we're going to control the process so that our product is better quality and a better efficiency. Now, why efficiency? Efficiency how? In times. Efficiency in material saving. It's not the same thing that if we have a well-programmed machine and it's repetitive, and this is something that I also forgot to mention. Industrial automation is a compound instructions where we tell the machine what to do. Okay? So we should be able to speak their same language. In this case, programming language, and that the machine also knows the instructions that we have to provide. So this ladder diagram, ladder diagram programming, which this is a language, the PLC language, this is the one that gives orders or receives signals for our PLC. Okay, let's go by part. I don't want to confuse you guys. Now, if they are repetitive tasks, that's going to decrease errors. So the machine runs certain activities, and if it complies as far as signal reception goes, then the machine is going to do this again and again and again and again, and quickly also. And it's also going to do it uh, correctly and surely. Because if we do the same thing once and again, if we're operators in an industry, they get tired very quickly. If they're packaging a certain product within a box or someplace, at some point, it's going to be normal. They can be able to make mistakes. How long does it take? That we don't know. But why? Because they might make a mistake from 1 week out or 1 month, and it's perfectly normal. We can make mistakes. That's why there is industrial automation. We are going to help companies produce their product with these characteristics. Okay? Now, this is precisely what I was saying. The image that we were shown in school when we were kids, what did they say? Actually, this process is to be able to deliver wooden sheets. This could be for flooring. This could be for a eucalyptus plantation. This company, for some reason, they saw some advantages, or they're providing some advantages for their clients with the eucalyptus plantation. I honestly have no idea. But we, as engineers, when we found industrialization, just analyze what products do we have at home. Okay, so for example, two products. What else can you see? A car that can be used as a product, but within that product there are more products. And what companies do is they develop the technology so that that company gets their seats, the wheel, the steering wheel, the gearbox, the electronic part. It's a world of products. Now, going back to the process, what else do we do here? We have a raw material, we cut trees, and then from here goes to a conveyor belt, and then it goes to a mixer. Okay, so each product has its own process. Are they the same? No. We, as automation engineers or programmers, we need to know all the product. Do we need to know all the processes? No. But our experience calls us out to be related to whatever company there is. But it can either work out for the process where they're working for whatever company we're working with, where we need to program for a company where they're making, let's say, for example, soaps or soap or chickens. It's not the same as this, right? Companies with lower temperatures, for example, to control our lower temperatures, which in these cases is refrigerators, etc. It's not the same thing as this. These products are not the same to cell phones, for example. or these products are not the same as the making of a pill or medicine. Okay, so okay, they are selling us and they are giving us the final product. But now we need to analyze what is their process for that product. And overall, for all the processes that they're showing us, what is the process for which I'm going to intervene or where I'm going to improve the system? Now, I told you behind a little while ago for processes, but it's not only for processes. It can also be for a specific process, okay? But in general, it's related to more processes. For example, this is a process. This is another process. This is a different process with mixing. Now, this is another process. This is the forming part where this we are able to see the preparation to take it to the press. And the press bed has temperature. So each process is different. And then what's it say here? We also need to add the sheets to an oven, which is heat treatment. And then comes the humidity process. And then quality control. And then all the way to the end, we have our logistics part, which in theory, we would have from here to look from here to here. And then the logistics part, in theory, we should not be involved in this, but there are automated warehouses where we should be able to, to dive in a little deeper because we also may have some predefined process. So all of this, guys, all of these processes, I want you to see what's the reason for being. So for example, here, up to which point would we have industrial automation? In theory, from here to here. Could be other companies like Lego who who all the way through over here in the logistics part. If you check the responsibility that we have as engineers in industrial automation, it's very big. That's why we get the big bucks. That's why this is one of the best paid careers. Now, maybe people don't take us too seriously, or since they're not very used to this career, maybe this started, let's say that it's been evolving quite quickly, actually. But it's not very well known because not everyone is worried about the processes that are behind everything. Okay, so that's our job. Make companies' lives easier and get production out so that it gets to people with the best quality possible. Now, if you say, well, it doesn't really have that passion, well, that's a completely different story. That's why we should run our repetitive processes and make them more efficient and with the best quality available. So each company is going to give you the recipe that your cake should have, which in this case is your final product. And why? Because it's not the same thing to have one project to whatever project. And now, since we're not experts in a process, we are experts in controlling our variables for this process. So we should then have our opportunity for this notion. Now, having said this and explained this, where we have our path right from the beginning, from raw material to that conversion to the final product, okay? I would like us to analyze example number one for this first product. What is it? No, it is not a glass of milk, but let's focus only on the empty glass. Now think, guys. There's two types of processes for this product. It is the manual process and the automatic process. The manual procedure, we do not need to be experts. You can check this in a chat GPT or Google, but try to not cheat. How long do you think it takes an artist, a specialized artist? Maybe he's not an apprentice or an intern, but how long do you really think it takes to make this product manually? What do I mean by manually? I mean this, as you see, where you put it in an oven, take it out, shaping it. How long do you think it takes? According to data that I've been researching, between 5 and 15 minutes, one piece, approximately. Now, also, I can't say for real or in general, but maybe someone has a little bit more experience on this and they know how to run these types of bottling or bottles. They can take less than 5 minutes. But there's always room for error. No matter how much of an expert you are, you can still make mistakes. Or maybe the bottle should fall and it would, break or overheat it, and then you have to reshape it or gets bent out of shape, and you still have to restart that process from scratch. If it's an artist who uses a lot of detail, they may be able to say, oh, well, if you want quality, this is going to take a little bit longer because I can only hand out one. Now, let's think on the other hand. Let's think outside the box because companies, they hire us to solve problems and to think outside the box. Not so much because of the title. But if you pay attention and if you skip this type of learning, with learning the core of why we should learn industrial automation, and this is important, I think this should be of great help. Now, the automatic process. Now, I understand this video is sped up, but it's not that sped up. The question here is, how long do you guys think? And in that period of time, can these units be finished for these bottles? Pause this, investigate, check it out if you wish. And if not, here's the data. There's all types of machines. Again, it's not about making general assumptions and saying, well, all machines have this process and all bottling factories have this and the time is this. It's not really that. There's older machines, there's newer machines, there's more recent machines, which have a lot of production. Now, how many rows do you see here in this process? I don't know which part of the process is, but I'm focusing on this apparently looks like the final part of the process to move to a certain part of the conveyor belts. And if it uses servo motors, which most likely it does, servo motors are very quick, people. Now, this is 15 to 30 seconds. Okay? And there's much quicker machines, but we're going to, in average. But this is per machine. Here we have 1, 2, 3. Here we have other 3. We have here in the back other 3. So it's 9. And check how many more are there. They're not crashing. They're not bumping into each other. And we control all of this thanks to programming or industrial automation. So if the pieces start falling together, you can start seeing why the PLC simulator is so important, why the app that you have in your hands is so important for your careers. Okay? Industrial automation is based on processes, and the exercises that you have in your hands are processes, and these are different processes. There's much more different processes, one from the other. For example, it's not the same thing to run a mouse for your laptop or computer, but there's other products that may seem very similar because we may have to work on automation or automotive automation. But the process is also very, very similar. Shh, you don't have to tell anyone. But if we have to resolve things that are related to a process and our experience makes us turn to a different process, that could mean that we don't have to overcomplicate ourselves with that company where we've worked before in our previous process. But that's only based on experience. Our PLC simulator application is that you don't necessarily have to wait for whatever time, and if so, make mistakes in your cell phone, not in the real world. Okay? Explode your traffic lights or your trains or whatever process you have there. Make the bottles fall. Okay? You have a very intelligent algorithm. Okay? So, mess up on your app. Now, if we move on to example number 2, manual process versus automatic process. If you guys think the same as I do, which in my case, I'm a horrible cook. I don't necessarily think that I'm a bad cook, but I experiment a lot. And unfortunately, I'm very slow when it comes to cooking. Okay? I don't really finish all of this. Now, hotcakes or pancakes, depending on how they're pronounced in your country, but pancakes, for example, if they're manual, and I'm giving you these data, for example, how long do you guys take to make a pancake, to prepare a pancake? Like, how long does it take and how many can you do? How many can you produce? In my case, I take between 40 and 60 minutes. I told you guys, I'm very slow. And I ultimately make between 10 and 15 pieces. Don't think, even though these images, they're very pretty, but I ultimately burn them or they're very small when they come out. So as I was saying, it can't be the same thing with me, guys. Now, if we go to the automatic part, because yes, there's an automatic part. There's a pancake making machine, and they're already in a very similar process. Or our hotcakes would be thrilled if you guys work in a similar process, or in the process as itself in bottle making. Okay, I'd like to see you guys. Now, let's go to industrial automation. Check how fast, guys, this works. This is a part of the process, guys, where they're flipping the pancakes. Pancakes are being flipped, and it tells you how often do they have to flip them. okay? It has to do with times so that they don't get burnt. So it's a perfect circle process, okay? Now, time for the truth. There are machines where in 16 minutes they make 6,000 pancakes every 60 minutes. It's crazy. And there's machines with more production even. Now, with which procedure are people going to get angry when they don't have their pancakes? With Rodrigo, with me making you pancakes, or 6,000 pieces in 1 hour? How long would this take? No sleep, even. How long would it take for me to make 6,000 pancakes with no sleep? 150 pieces per day. In 10 days, I would be able to make 1,500 pieces, which is only a fraction of what this machine can do. In 40 days, I would make the same as this machine makes in 1 hour. This is what companies are looking for. So you guys keep that in mind. Now, this is our proof. A machine that we were looking at, 6,000 pieces per hour. It's crazy. There's smaller machines or there's smaller pancakes, but we could be able to create this control. That's why this job is very solicited. I mean, honestly, when I'm cold, I put on my sweater or a jacket. If I want to have fun or if I want to buy something, remember, there's also consumables. This on the foot part for products where if I want a chocolate, I'm going to buy it myself. Okay? So the chocolate wrapping, that's another product. But as I said, it's a whole different product. Everything is digitalized, everything is automated, but nothing is removed anything from the people. They still buy products, and product is still being developed. We still get new products, and so we have a lot of work, guys. This is until at least people start diminishing. And this is going to happen until approximately 2050, 2050, the year 2050. So if you want to be a part of this incredible workforce, you need to work and really work hard. Because also, you need to like this. It it would be no good if you have a job to do and you don't really enjoy it. So every every job has a burnout process. Even a lawyer who loves his job, they also get fed up with their work. I mean, people love their work. Yes, a veterinary, for example, he loves his job also, but because the population is so much and there's so many people, there's more pressure, guys. So that pressure, I've lived through this. Even though I love my career and I love everything that I've lived, there's certain times where customers ask so much of us that we burn out and we want to throw in the towel. So imagine when that happens. And this is for everyone. That burnout in a company or a career that you don't want, that you don't like. If you do this for the money, you're going to get burnt out much quicker. Okay? So I wanted to tell you guys that you need to choose your career wisely. If while I'm talking to you, you get thrilled and you say, Rodrigo, hey, please hurry up, man. Come on. I need to learn how to program. I want to see how things are moving. If you have that, you know, if you have that, that career, this career is for you then. If not, continue investigating, continue researching into other branches of this career. But for those of us who are here, it's because we love giving life to machines. We love to make processes more efficient. Much easier things where that condition and that change made production more efficient, which, trust me, it's a great advantage. It's something beautiful when they call us to repair or when they see that there are between 5 and 10 engineers that haven't found the solution and we say, oh, don't worry, guys, we can review this and analyze this. And we get to our solution. That is magic. And that is incredible. Now, that was just a small parenthesis. But now, how do we control our processes? If we're saying that it's about improving quality and programming in the PLC, but how do I really control my processes? This is an incredible question, guys, and we need to analyze this simply or in a simpler way. Because then complex questions we need to analyze right from the beginning. So there's a phrase, and this phrase is used for product management, startups, because they analyze a lot of data, and especially for us. Because what you can measure, you can control. All that you can measure, you can control. All that through which you can get data and measure data, you can control. That's the phrase. Now, I agree. Also, there are certain things that are obviously out of our control, but can't be measured. But we still can try. Now, these are tangible things. Now, again, don't overcomplicate things. Okay? We can't control other people's emotions. We can't control another person. We can't control ourselves through their emotions, which in theory we can, but that's a whole different thing. But nothing is guaranteed where we can control anyone through their emotions. It's something unethical, even. And also, there's not really a way that people respond the same way. So if people say, well, I need you to grade this survey through a happy face or an angry face, we can continue uh, trying to improve our process to better a product. Okay? Now, what can we control? What is measurable and controllable? I mean, I'm talking about tangibly. For example, variables. All variables can be measurable. These can provide us characteristics for data through which we can chart out and respect. Now, let's do a drill. What is this, guys? A watch. What does this represent? What variable is this indicating? Time. Now, how do we measure time? Through seconds, hours, minutes, years? So then, can we control this? Of course we can. A PLC allows us to control time. Or, I don't know, I need for a certain process to be there in our oven. Let's say, for example, bread. It needs to be in the oven at a certain temperature for whatever amount of time. And our PLC can limit that time, and we can, through that limit, ask that for that period of time that you heat up my bread, my loaves of bread. Okay, so that's controllable. What else? We have a sun here. Can we control the sun? Well, we actually have the sun as a representation and also a snowflake. These are for you guys. These are not universal symbols. It's for us to understand. And honestly, this explanation, no one else has this outside of this course. So I'm providing this, and I'm also weirded out because these are very obvious things in which industrial automation is based on. But I'm explaining this to you so you guys can understand it better. Automation is a complex topic, but also something that has worked for me and something that has worked for our colleagues and our other workers is we've been able to handle different processes for which they say, well, a certain person tried it and we can't do it and blah, blah, blah. Complex things that our customers indicate we can always solve. And also, these are very simple uh, processes. Sometimes people overcomplicate themselves, and we can oversimplify. So we need to understand the concepts. So trust me, with this, you're going to be one step ahead when it comes to understanding industrial automation. And it's going to be much easier for you guys. If you don't know these processes, trust me, this is going to be much quicker when we move on to automation. Now, sun and snowflake, what do they measure? Temperature. They represent temperature in Celsius or Fahrenheit or Kelvin. Okay? Now, these are measurable. Or the temperature variable. Can we control this? Yes, we can. And there's many different ways. But also, the most important one is to send out a voltage through a resistance. Now, who sends this voltage? Our PLC. And we're going to dive deeper into PLCs and their components. And we're also going to explain in a simpler way so that you guys can understand much easier this process. Okay? You guys are going to be able to understand many complex things without getting too technical. Okay, now times, the PLC control. Temperature, also the PLC. Now, what is this? A water drop. Humidity. We can control humidity in the air. How? Well, we just light up a fan. Why? So that it can eliminate humidity. Or we need to activate to regulate humidity. Okay. Now, there's the percentage part where, for example, we have our dew percentage or directly humidity percentage. Okay. Now, we can also control humidity through our PLC, which help us control our humidity degree within a lab or pharmaceutical plants. Okay, this is where they use this a lot. Okay, what else? This is like our streak that we're counting on. Now we can also account for production. Yes. Now, which variable is this? The production variable. And we can count this. Units. What can we get from these countings? From these counts? Eggs, chocolates, units, pieces. Can we control this? Yes, we can. Because let's say that we have a process for pencil manufacturing. And every 20 pencils, we need that the conveyor belt is sending these pencils so that from there, those 20 go through another process for packaging. So we need to indicate and we need to refill these boxes with 20 units, 20 pieces. So we count 1, 2, 3, 4, 5, 6, 7, whatever, 20. Now, when we get to 20, we stop or we add a piston so that these can wait. The other pieces can be, right there on hold, and we can also control that. Okay. Now we have that control, but how? Thanks to our PLC, where it has internal controllers. Now the auditive part we can also use because we also have sensors that adjust decibels, which are the speeds for the auditive part. And also, we can also detect noise detection, okay, where we can also increase or decrease in our alarms. So, can the PLC control this? Yes, there are systems. However, these are already critical in the auditive part. Now, we can also push down the audio level, push up the audio level, and this has to do with the sounds part. Now, obviously, there's certain electrical processes, but these types of concertos and events are the ones that we regularly need for that auditive part. Okay, we also have sensors that are very, very critical or very receptive when it comes to noise. We also have even uh, through a guitar, it starts telling us which note is wrong or which one do we have to pay more attention to. Now, there's also devices that allow also the automatic adjustment to the clothing that a singer is wearing. Now, other variable, weight, where in units could be kilograms or grams or whatever you wish to add. Yeah, you guys can also control this. Now, as I was saying, for this one, for industrial engineering, for industries, and all those kinds of things, where it's very, very, very primary to lose pure air. Now, to what percentage? That's something else that we're going to look into further down the line. Each product is different, and they each have different variables to control. They have different ranges depending on the product. Be careful with that. The economical part, because I'm going to be honest and realistic. If the industrial automation company is well paid, it is because if we run a minimal change which benefits them, this is translated into this, the economical part, which in the end, if we produce more and we make the other company for which we got hired from get better production or better quality in our products, people are going to come back or they're going to consume more. And what's going to happen is the same company is going to continue hiring us. Maybe not for that process, but for another migration or something. And that translates to an economical part. So companies look into the input part, and if it's decreasing, then something is going on. Okay, the very famous inputs and outputs, but that can be controlled. And also, in this case, if we run, for example, a project for the Bank of Mexico, where we created an accountant and it was counting money, then all these types of things or all these things work depending on what we want to control. Now, another variable here, in this case, I have a pedometer or a speedometer for motors. Now, what do they use? RPMs, or thanks to our drive, we can control those hertz from 0 to 60 here in Latin America. And 0 is our minimal speed. So through this, we might be able to control this because we're getting to half of our speed, whatever that motor is able to assign us or help us. Now, which variable is here? Speed. What units? RPMs, hertz, whatever you wish. And then we move on to one of our most popular ones, voltage. Sensors, photoelectric devices, okay? Level sensors or luminosity sensors. And this is translated to voltage. If my sensor gives me certain data or certain voltage, then that means that this equals to, depending on what we wish to measure. Okay? And then we move on to scaling. And then we can also control that voltage thanks to our PLC. For example, 0 to 10 volts, or we can also control current from 0 to 1000 amps, depending on what process. Now, this is not a stipulated rule for everyone. These are many variables. Now, another one. I also added a card here, not because of speed, but distance. That's a different variable. Okay? So conveyor belts. If you wish for it to move 20 more centimeters, how are they measured? Through centimeters, millimeters, meters. Now, this we can control. Okay? Now, going over this. If you can measure it, you can control it. Okay? All of these we can measure. So therefore, all of these we can control. Now, we're almost done, guys. I just want to show you guys all careers which are focused on industrial automation and PLCs. Why? Because then we have engineers or non-engineers, which honestly, that's what's sad about this. That's why I'm showing you this in this presentation. Because then other engineers that don't have this career, but they like this PLC programming, they do very well because they have the passion, they have the logic, and they show up in companies. But if we are able to show our knowledge and to show that we're good in this, at this, we can get jobs easily. Even if you say, well, I'm just getting out of high school or whatever, you can still start with this. Don't wait until we get to 8th or 7th semester to start working on this when you start looking into something related to electronics. Don't wait it out, guys. Try learning beforehand. And this is a guarantee that I have for you guys. Doesn't matter what level you have. You can start now. PLC programming. I guarantee this. And once you get to that special project for that special semester, you're not going to be a blank slate. Okay? Generally, in school, they give us the general knowledge course part. And I thought that school was going to have more labs or whatever labs it had, we were going to take longer, which is basically all of our career. So, but it's not always like this. It also happens with private schools. Okay, so these are expensive courses where they're not really all that popular. How are we going to be able to practice? There's so many students, so many people. It's not the same thing that I have my computer and that I'm programming PLCs, even if it is virtual. But at least give me an opportunity to practice. Okay? Not something where it's, saw us in 2 semesters and we're done. Okay? So we need to be very careful, guys. Practice now. Start practicing now. That's why we're here. That's what we're here for. Automation control. Okay? Automation control and engineering, I've seen this everywhere. But they are working hand in hand. Mechatronics. There's obviously a lot of mechatronics engineers that know how to program PLC. Industrial robotics. Robots are based on CPUs, brain power. Fanuc, for example, works with PLC systems, but also the robotic industrialization works with PLCs. Okay, so they also use this and a lot. Logic is very, very similar, especially in motion control. Electromechanical technician. Okay, if you're carrying out this type of career in school, or you already have this and you're technicians, get close to the fire, baby. Okay, electronics, electricians, programmers. What type of programmers? Any kind of programmers. Programmers have certain conditions. They need to know how to program and what would happen if, their ifs, their ands, they have a variable part, and what would happen if the parallels. So it's all very similar. Okay. And when I say application programming for software, this can be used. So in our team, for example, half of our development team for this software specifically, and the other one, the surprise one, they are software programmers. And in the end, everything that they've learned, they know how to program PLC. So they had to have learned to program. And it was very quick with the way that this was explained. So don't worry, guys. If you guys are interested in this career, trust me, get close. Industrial engineering. Oh, well, I was never a programmer or I programmed something very simple. Guys, you know about processes. I think you guys even know more than we do when it comes to processes. If you're interested in programming, come closer, okay? Because if you have the notion on how whatever process works, if you know which variables we need to control, then all you need is the logical part. And how are you going to explain this to your PLC? And if you don't want to be a full programmer, it's also good for you because if you're a branch manager or industrial engineer and you have your team of automation programmers, no one is going to make a fool out of you because you already know how sensor works, how the button works, and this helps. Okay. So again, this could also work. And obviously, uh, systems and information IT departments. Now, this is why we need a lot of engineers for the IT part, especially for the IT parts. Okay, so you also need to know a little bit about PLCs and you want to get deeper into the industry. This is also for you guys. And in summary, we're going to summarize 4 advantages when it comes to industrial automation, which is basically what we had previously said. It's all about advantages. I had previously said this, and I hope you guys understand this. The mix of processes and activities in which raw material is converted or turned into a final product or an end product. Or the part where we have electronics or where we have programming. All of these technologies, specifically speaking or talking about programming, because we have software programming, but that's a different topic. This is industrial automation, industrial programming. Okay. Now, this decreases production time. Yes, it does. But it's not the same thing. An automatic process where we decrease uh, labor incidents. So, because of the same thing, a machine, you need to automate it and you need to maintain it. You need to provide some maintenance for machines where Sometimes some machines run for 6 months or a year, and it's incredible. Okay, it's a lot of production that they have. So it increases production considerably. The top part is time decrease, and the bottom part is product increase. And finally, improves the final quality of the product. I hope you guys like this, and I hope that you guys were, or this topic would be, is closer to you guys. Tell me in the comments next to the video on this section for our PLC Animator courses. Now, without further ado, let's go to our next topic. We're going to see our topics, our concepts, and now we're going to work a little bit more with our PLC. What is our PLC and why is this the focus for industrial automation? I'll see you guys in our next video. Big hug, guys. Thank you very much for your time.